All right, folks, we're diving into 9.2 quadratic inequalities. And we're going to do two different versions of this. We're going to do one variable, and then 9.3 is two variables. So what I know is that you're pretty good at this. This one is nice because you're not going to graph it per se on a graph paper, but you are going to have to make a number line solution, which isn't the end of the world. And we're going to go from there. Super easy. Okay, so why it's called one variable is, I'm just going to slide down here. You see that we have an x and an x squared, but there's no y. So if you only have one variable right away, you get your x and your x squared. We consider those the same variable. They have different degrees. So if there's no y in here, there's no second variable, like a's or b's or whatever, you're going to have a number line solution. Oops, number line solution. So if you're wondering what's the difference between the two, if this was equal to y or, less than or equal to y, you would end up having to graph it on a piece of graph paper like we talked about in the last video. Okay, so this is like chapter 4. So we're taking time away from grade 10 and we're dumping into chapter 4, but we're adding more to it now. So anytime we're going to solve a quadratic, you need to set it equal to 0. So 0 on one side, everything else on the other. And it talks about using sign analysis to solve the inequality. You don't have to graph it. The sign analysis that we're using from graphing rational functions. So by the time you watch this video, we will have finished graphing rational functions and you'll know what I'm talking about. So these are the steps. Solve for the roots. And so when we're solving a quadratic, we have two strategies. We're going to factor if that's easy. And if it's hard, we're going to use the quadratic formula. And just to remind you, your quadratic formula is x equals negative b plus minus the square root, oops, I'm running off the page, b squared minus 4ac, all divided by 2a. And I know some of us are still having trouble putting it in the calculator. So if you envision brackets on the top there, you have to do everything on the top first before you divide it by the 2a. So just keep that in mind when you're doing your quadratic. Plot the roots on a number line. So when I'm talking about a number line solution, you did this in grade 9, but that was a long time ago. A closed circle means that it includes that point. So that's going to be your less than or equal to or your greater than or equal to signs. If it's a less than or a greater than without the equal to sign, we use an open circle. It just means that it doesn't include the point. You're going to pick some test points, just like we did before. You're going to substitute test points into the original equation, which we always do when we're doing a check, and then we're going to state the solution. Okay, so pretty straightforward. You get a break from graphing, but not for too long, because the next lesson will have graphing in it. Okay, so factors of 16 that add up to a negative 10. So I'm looking for the factors of 16 that add up to a negative 10. So that would be negative 8 and negative 2. So I'm just going to go ahead and, oops. So just like an equation, we can't really lose that equal to sign. So what I know is that on my number line, my points will be closed because I have the equal to sign. So I'm going to set each factor equal to 0. And I'm going to solve. Okay, so that's not hard. I did that. That's pretty good. So I'm going to put my number line on my page. And I like things to be straight, so I always have a ruler close by. And I'm going to put some increments on here. And why did I pick that many increments? I don't know. It was what I drew the line for. Okay, so we need a positive 8 and a positive 2 on the number line. So if I'm going to say that's 0, That's 2, 4, 6, 8, 10. I guess I can keep going, 12, 14. Okay, so you get the idea. It's like the increments on a graph. You don't have to list them all. That's not required, but you do have to list some. Obviously, we're going to have closed circles, and I like to put them above the number line, like just, we're going to have closed circles at 2 and at 8 because they represent our solution. So now we're going to see, where does the shading happen if I were going to relate this to a graph? So we're going to see where our solutions are. So we got to do some test points. So I'm going to pick a test point, and I'm going to pick one. So we have an area here, we have an area in between, and we have an area to the right. So to the left, middle, and right, if you think of it that way. So I'm going to pick a test point to the left, which would be when x is equal to 0, and I'm going to substitute it into the equation. So I'm going to have 0 squared minus 10 times 0 plus 16 is less than or equal to 0. So 16 is less than or equal to 0. That is false. Okay, well, that's good to know. So with it false, I know it doesn't exist out here. So now I'm going to pick a test point in between the two. So I'll pick 4. I try to pick small numbers so I can actually try to do the math in my head. So I'm going to have 4 squared minus 10 times 4 plus 16 is less than or equal to 0. So 16 minus 40 plus 16. 16 minus 40 is 24. Negative 24 plus 16 is less than 0. And so that's going to be negative 8 is less than 0. So that is true. So I know that it works in between the two. That's good. And just for funsies, I'm going to pick a test point beyond that. Do when x is 10. So again, I'm always going back to that original equation. So I have 100 minus 100 plus 16 is less than or equal to 0. So 16 is less than or equal to 0, and that is false. So I'm going to put my answer. I know that my answers work between 2 and 8, and they also include the points 2 to 8. So I have to indicate on my number line that those points exist. Now we're going to write it as a domain statement as well. So what we're trying to say is that x can be any values between 2 and 8 and including both 2 and 8. So when we're going to do a set notation, and no one likes set notation. And set notation has the fancy brackets. So the first thing we do is we define our variable x. We're going to draw a line, it's kind of big, and then we're going to make a statement. We're going to make a statement about this. So we're going to say, we always put the lower one on the left, we put our variable in the middle, and we put our bigger one on the right. Because these are closed circles, because it was here, we are going to point all our arrows to the left. And that statement says x has to be greater than or equal to 2, but less than or equal to 8. And that's really what we're trying to say. We're going to finish that off with some fancy brackets. And so if I ask for a domain statement, that's what I'm looking for. Okay? We're going to do a couple of others that are a little bit different. Okay, so this is our first one. And again, if you need time to, if I'm going too fast, I'm in a room by myself. So if I'm going too fast, make sure you pause the video, make sure you rewatch it on YouTube, or it's in the Google Classroom as well. If you need it in both those places, that is where you can find it. Okay, and the link will be also on your Student Connect. Okay, so moving right along, we're gonna go do this again, but with a different one. And we're gonna try to speed up just a scooch, just a little bit. Okay, so this looks like simple factoring, but it's not. Oh, geez Louise, it's not. This is complex because it actually has a -1 out front. So let's walk through complex factoring. So -1 times 10. So I'm going to be looking for the factors in -10 that add up to a +3. So that's going to be a +5 and a -2. So we keep the -1x squared. I'm going to do -2x next, plus 5x plus 10. Oops, no equal to sign, less than 0. Okay, so we're going to go ahead and look at these two. We're going to common factor something out. I'm going to take out a -1, and I'm going to take out an x. So I'm left with x plus 2. Because if I multiply this back in, it should get me back to here. And then I'm going to look at these two, and I'm going to take out a +5. I'm going to be left with x plus 2. Now, I know I've done it right if those two things are exactly the same. Now, we're trying to find our boundaries, so I'm going to switch this inequality just to an equal sign for 1 second here, because I just want to find what the actual points are. So I've got -1x plus 5, and x plus 2 equals 0. So these are kind of my boundaries. So I'm going to have -1x plus 5 equals 0, and x plus 2 equals 0. So I'm going to have -1x equals -5. So x is equal to a +5, and this will be x is equal to a -2. So those are my boundary points. Those are my boundary points. So I'm going to go ahead and get my ruler out again, and I'm going to draw my number line. Since I have my ruler here, I'm just doing the increments, like I'm drawing a line and I'm throwing increments on it. There's no real rhyme or reason. If I put 0 here, this will be -2, that'll be +2, 4, 6, 8, and that one would be -4. Okay, that one's not too bad. Now do I have open or closed circles here? Do I have open or closed? I hope you're all showing that they're open, and I know they're open because there's no equal to sign there. So I'm going to have an open circle at 2, and I'm going to have an open circle at 5. So again, I'm trying to figure out what values work, the outsides or the insides. Am I looking at the outsides or am I looking at the inside? What works? So we're going to pick some test points, and this is where we're going to go just a little bit faster. I'm going to ask you to do some stuff in your head. Okay, so there's a reason why we call this sign analysis, and the reason why is because we know in order for this to be true, what's happening on this side has to be negative. So it's sign analysis because it doesn't really matter what negative number it is, it just has to be negative. But let's do some math here first. So I have a -4 squared, which is 16. 16 times -1 is -16, minus 12 plus 10 is less than 0. That's a -2, so this is going to be -18 is less than 0. So as long as it's negative on this side, I know that's good. So I know that out here on my number line works. Now that tells me a couple of things. That tells me that I anticipate if this works, then this outside will work and the inside won't work. So it really depends on how much you trust your math. Some of you will say, oh yeah, I trust it. No problem. I don't even have to do it. And that's okay. But I would encourage you all that we all make mistakes. We all do simple math wrong sometimes, and that you should always double check. So I've got 10 is less than 0. That is false. So what I know is it doesn't work in between those 2 points. So I'm going to test my last point, which is to the right of 5. Oh, that's not. Oh, geez. Who put that point there? That's at 3, not at 5. I hope you guys have better notes than I do. Look, it's like it never happened. Let me put in the 5. Okay, so we're going to pick 6. So we're going to have negative 6 squared plus 3 times 6 plus 10 is less than 0. So we're going to have negative 36 plus 18 plus 10. So we're going to have a negative 8 is less than 0. And that is true. So it's true in 2 places. It's true out here and out here. So we know, and I'm going to put an arrow on this, and I'm using a highlighter just so I can significantly see the difference on my number line. So we know that it doesn't occur in here, but it occurs out here and out here. It occurs in 2 places, which is fine. So now we're going to make our domain statement about that. So again, we're just defining our variable x, drawing our big line, and we're going to make a statement about x. X, if you have 2 arms, you're going to have 2 statements. X is less than negative 2. That takes care of this part of the wing. I call it the arm. And you'll understand a little bit more why I call it the arms when we do 9.3. This part happens as well, so we know that x has to be greater than 5. Now these 2 things happen at the same time. So in math we say in unison with. So we have a U, but it doesn't have a stick on it. It's Greek, I think, but that's the symbol for it. It's a U without a stick. And we use our fancy brackets. So that's how we do it when we have not a connected, but 2 different. It's that unison right here. And you've probably never seen that before. Maybe you have, but we just see it for the first time in this one. Okay, moving right along. So don't forget, if I asked for a domain statement, that's what I'm referring to. Okay, second last example. We're almost there. So what we're going to do in this one is, this is kind of like a trick one, but not really a trick. We know anytime we have a quadratic and we want to solve it, we have to set it equal to 0. So we have to minus 10 from both sides. So we've got x squared minus 4x minus 10 is greater than 0. When you add or subtract, it doesn't affect the inequality sign. It's only when you're dividing by a negative coefficient that it will switch the inequality sign. Okay, so now what we're going to do is we are going to say what are the factors of negative 10 that add up to a negative 4. None that I can think of. 2 and 5, they don't go to 4, and 1 and 10. So this isn't an easy one. This is where we have to use the quadratic formula. So we know our a is 1, our b is negative 4, and our c is negative 10. So we're going to use our quadratic formula here. So x is equal to positive 4 plus minus the square root negative 4 squared minus 4 times a times c all over 2 times a. And again, we have to do what's on top first. And I have to say, like, if you find factoring like that isn't working for your brain, that's okay. Use your quadratic formula. I just find that factoring does go a little bit quicker. So when I put this in my calculator, it's kind of hard to see, sorry. I'm going to do my 4 plus 56 first. 4 plus 56, I'm going to hit the equal sign, and then I'm going to divide by 2. And I'm going to go to 2 decimal places. So I always take care of that numerator first, so 5.74, and this side will be 4 minus the square root of 52. Okay, not super nice numbers, but that's okay. Like, they're still numbers, they still work. Nothing's too terrible. We're gonna do it the exact same way we just did the other one. All right, so there's my number line. I have a negative number. So if I make this -2, that'll be -4, it'll be 0. Okay, so we only have a greater than sign, so I know my circles are going to be open. And I know I have one that's going to be close to 6. And I'm going to have one that's going to be close to -2. So again, I got to figure out, are my values inside or outside? And so let's do true sign analysis this time. So if we look at this, does this have to be positive or negative in order for this inequality to be true? So we know that this side has to be positive because positive numbers will be greater than 0, okay? So we're just going to dump numbers into here. So let's take -2 because that's less than that one. So -2, if I put -2 in here, so I'm going to have 4 plus 8. Let's do it down here. 4 plus 8 minus 10. So 4 plus 8 is 12. 12 minus 10. Okay, it's positive, so I know that that works. I'm going to pick a number in between. I'm going to pick 0. So if I put 0 in here, I've got -10 is greater than. I know this doesn't work. And then if I pick a value greater than that, I'm going to pick 6. So I'm going to have 36 minus 24 minus 10. So this will be 2 is greater than 0. That works. So that's how I do sign analysis. It's figuring out whether it's positive or negative. If you don't like that, because that just went too fast for your brain, go back and do test points. It's the exact same thing that we just did. So it just goes a little bit faster if you do it this way. But it's all what makes sense to you. It's not about, there's this fine balance between really truly understanding something. It's like you've got to get good and then you get fast. So if you're still working on the getting good at it part, then take your time with it. But once you get good, then your goal should be to get faster. It's about being efficient. Okay, so we've got the arm statement just like the question up here before. They're just not pretty numbers. So we're going to have X, big line, and we know that X has to be less than, no equal to sign because it wasn't in the equation, -1.61. And we know that X has to be greater than 5.74. Those two things happen at the same time, so we put the U in between and we put the fancy brackets. And that's a domain statement. Okay. There we go. Less graphing. And I don't think this is too hard. You just got to slow down and think about the pieces. And I'm sure you're all saying that's all fine and dandy for you because I do this every year. But I think if you slow down and think about it, it's just grade 10 and it's chapter 4, but with an extra piece. That's all. And if this is really confusing to you, we can come back to it and revisit it, but just read what it says. And if you're looking at your answer key, read in your head what it says. Say it out loud. Start at the variable x is less than negative 1.61. Okay? I always start at the variable and I read my inequalities that way. Okay, next one. Last one. Woo. Suppose a baseball is thrown from a height of 1.5 meters. The inequality given is stated there, models the time in seconds that the baseball is in flight. During what time intervals is the baseball in flight? So really what I'm looking for is I'm looking for the x-intercepts for this. This has nothing to do with the question. Sometimes it will, sometimes it won't. You have to learn to distinguish look for this number in the equation. If it's already in the equation, don't worry about it. If the inequality is modeled. So we're trying to actually solve for the x-intercepts because we know this graph is going to open down. And we know that this would be time and this would be height. So what we're looking for is when the ball is in flight. Now, it's going to give us this and it's going to give us this. What do we know? We know time can't go backwards. So where does our graph start? Our graph is going to start at 0. And it's going to continue on till it hits the ground. So the in-flight portion is this area right here. So we just got to figure out what time it hits the ground. So really, we're going to have to use our quadratic formula because none of this is nice. None of this is nice to solve. So A is equal to a negative 4.9, B is equal to 17, and C is equal to 1.5. And I always do this because it helps my brain keep myself organized, especially if I'm missing that middle variable. So T is equal to, now I didn't use an X for my quadratic formula because the independent variable is T this time. So T is equal to negative 17 plus minus the square root of 17 squared minus 4 times A times C. Got to extend that out. And that's times by 2 times negative 4.9. Anybody recognize negative 9.8? You might if you're in physics. Gravity? Anyway, just thought I'd point that out. 289. So T is equal to negative 17 plus the square root of 3.184, negative 9.8, and T is also equal to negative 17 minus the square root of 308.4, or negative 9.8. Okay, so I just got to solve these out. Sorry, I'm having trouble with my calculator. Okay, so we anticipated this. We anticipated that we were going to get, this would be my negative 0.91, and this one would be my 3.56. We know that this doesn't exist in real life. So we know that our t starts at 0. So during what time interval is the baseball in flight? So we're going to ignore this one because we know, and again, you have to be purposeful when you reject something. You really, it's not because it's negative, it's because it's negative when we're talking about time. I noticed in problem set number 2, people were rejecting negatives when they didn't really need to. It was talking about integers, and integers can be negative. So what we know is the ball is in flight when, so we're going to define our variable, t, right? We're talking about t's. We know lower limit, which is 0. We know higher limit, which is 3.56. We put our letter in between, and we know, and again, no equal to sign in the question, so there's no equal to sign here. Our inequalities always point to the left in our domain statement. So we are saying that the ball is in motion. So if I read this, I'm just going to ignore this for a second. So t has to be greater than 0, and t has to be less than 3.56. So you've just told me that it has to be anywhere in here. The ball is actually in the air. And that's it. Easy peasy, right? I'm sure you feel very confident. Again, if you have questions, please feel free to email them to me. Thompson is just down in room 215. If you have any questions there, she can totally help you in a pinch. Again, if things are going off the rails, don't panic. When we come back together, we will make a plan. We will see you very soon.